Hi kids! Today we're going to talk about forms of energy and heat transfer.
Okay.
So let's get right into the different forms of energy.
Sure.
So one thing to keep in mind is law of conservation of energy. So you know law of conservation of mass, law of conservation of energy means? What do you think it means?
Energy is, and that's what I'm writing right now, energy is conserved.
Okay, so not created, not destroyed, but transferred. So now let's get into the different types.
So energy is conserved, transferred. So how many different types are we going to look at today?
So there's 4 types, but there's 2 categories.
All right, so we'll start with, how about we start with mechanical? If we start with mechanical energy, what does that sound like to you?
Mechanical?
Like, what does a mechanic do?
Works on things.
Works on, okay, this is like physical stuff,
Yeah.
right?
Like
so
physics.
mechanical is talking about motion, and we have 2 different types of mechanical energy that we can talk about, one of which is kinetic.
And the other is potential. And these words should be pretty familiar. These are the definitions that you will have already known.
Right.
So kinetic's based on motion. Potential is stored.
All right.
So if something's up higher, it has a lot of potential energy. And once it's moving, it's transferred to kinetic energy until it hits the ground.
And how you can think about this with kinetic and potential with regards to mechanical is like somebody standing on a diving board.
Right.
When they're standing on the diving board and they have a long way to fall because of gravity, they have potential energy. Once they actually jump off, all that potential is converted to kinetic when they're moving. All right. The second type that we're going to talk about is chemical. Since we are in chemistry, we need to talk about chemical energy. Now, there are 2 types of chemical energy.
Kinetic and
There's
potential.
kinetic and potential chemical energy. So, important to keep these things kind of straight. So, mechanical, kinetic, and potential, and now chemical, kinetic, and potential. Now, kinetic for chemical is more about particle motion, and that relates mostly to temperature. So, this is motion of particles, but remember, as we've learned, it's all about temperature.
Right. So more temperature or higher temperature, more kinetic energy, particles move faster.
Right.
It should all be a review at this
And that was, and there was an equation for that, the K equals 1/2 mv squared. The chemical potential energy, though, it still is stored energy, but where is it stored?
So it's stored in chemical bonds. So when atoms combine and make bonds, there's energy in those bonds.
Right.
So it can be broken and released,
Okay.
or it can be stored in the bonds.
All right.
That's how we break down food. It's where we get all our energy from.
All right. So we really only have one more type that we need to talk about, and that is thermal. It's not just a really comfy shirt. It's a type of energy. So thermal means it's based on the transfer of heat. So let's talk about thermal energy and transfer to, how about transfer of, Mr. Bebe? Yes, I call myself.
Transfer of heat.
Okay.
So if we're saying transfer of heat, we're always going to go from hot to cold.
Yeah.
So energy will always move from something that's warmer to something that's colder until they reach the same temperature, and then the transfer will stop.
I'm glad you started mentioning that because I have here a glass of ice water. Now, as I hold this glass of ice water, oof, feels kind of cold. My hand is warmer, has more heat in it than the glass does right now.
Right.
So the heat is going from my hand to the glass at this time.
Right.
Now, something that usually blows a lot of people's minds, including my own when I learned this, is the ice that I put in my water. The ice is not really making my water colder. The water is making my ice warmer.
Wow.
Yeah, right? Pretty cool. So transfer of heat always goes from the warmer thing to the cooler thing.
Right.
So hot to cold.
Yep.
All right. That seems like it. Like we're done, right?
I think we are done.
Awesome.